Good morning, everybody. My name is Lee. This is my team, Kai, Jaffer, and Kaylin. Our topic is why fractals are relevant in today. So with that, I'm going to hand it off to Kaylin. She will start us off.
Thank you. Hello. So fractals are relevant because they are seen in every aspect of life. You know, from our nature to our bodies to art, even food and architecture. Okay, so for the first thing, in nature, so Benoit Mandelbrot was the first person to kind of push how fractals can explain the coastline and other aspects of the land, so we can help measure that. So another place that fractals can be found are in clouds. So fractals are a geometric shape that just keeps repeating itself. So it doesn't necessarily have to be just a curve. It can be a point as well. Like snowflakes, waterfalls, lightning, and so forth. So besides just nature, it can also be found in animals, the different patterns. So for this peacock, for example, you can see the patterns that keep repeating itself in its feathers that are spread out. And then this is a different type of fractal in the wings of a butterfly. And then again, these are the same patterns that just keep repeating itself in its wings. So fractals, like I said, can also be found in art and architecture. So this is an example of the Eiffel Tower. And on the right side, you can see how fractals are used to stack upon one another to get the geometric shape of the Eiffel Tower. And so the next place that fractals can be found are inside your body. This is a picture of your lungs, and this is a very simple way of showing you how your blood vessels are in your lungs, and the different shapes that they show, and how it keeps expanding out.
Those are bronchioles, by the way, not blood vessels.
Thank you. And so a big place where fractals can be found are in your DNA, with the repeating shape.
Helix is the word you want.
Helix. Thank you. Yeah, and this is just another example.
So with what Caitlin is saying, I'm going to bounce off of how it is in like medicine and nature a little bit more. So she mentioned lungs, so we're going to talk a little bit about the lungs. So doctors nowadays have technology like CAT scans and MRI machines to see the patterns inside your lungs, whether like it's a healthy lung or a bad lung. So that fractals play a really big part in that. And then next on nature, there's a group of scientists at a college, University of Rochester in New York, who actually implement and use fractals for soil erosion to predict like if it's going to happen and how big, how drastic it's going to happen. So with those, I'm going to pass it off to Jaffer. He'll talk a little bit more about technology.
Before there was the E equals MC squared formula. A lot of scientists had a hard time measuring the energy in the universe and measuring distances between atoms. It was becoming a crisis. They started getting frustrated. But when he came with that formula, they utilized it in a lot of scientific fields in physics and in what ended the Second World War. After after that, mathematicians sort of dealt with the same crisis when it came to measuring certain roughnesses, like mentioned earlier, like coastline patterns and more serious statistics and everyday equations. Then comes Mandelbrot with his equation that was kind of, it's a reoccurring equation, so what comes out the other side ends up becoming the input for the previous output. And it just loops one, and it comes out with two parameters. One parameter gets closer and closer to infinity as the pattern loops, and the other parameter comes closer and closer to a finite number. And yeah, just a nice pattern just to look at. This right here is something done by a scientist, I believe his name Edward Dubois, who studied weather patterns, and he's using this the fractal algorithm that I mentioned earlier with the recordings of weather patterns and finding ways to combat that. I think it's still being used today. And here's a slide I want you to
Go back. All right. Has anybody ever heard of the butterfly effect?
Yeah.
That's where it comes from. It's not because of an actual butterfly, like people tend to relate it to that story about a butterfly causing a storm halfway around the world. It comes from this. It comes from, this is the basis of what's called chaos theory, which is another class. Keep going.
In sound technology, when you go to a music recording studio, there's a lot of sponges on the walls, and when I was in school, no one knew what that was, but the technology is used to use micro fibers, sponges in the walls with really finite details that absorb the sound as much as possible. In this image, it's not really being absorbed, but most of it is being dispersed and diffused. So that's sort of like, that's an example of how it's being used. In computer graphics mentioned earlier in the movies, you can make very realistic, detailed recapturing the nature of things with a simple algorithm that doesn't take as much memory in the computer. This is a cooling chip used with many fine, detailed fractals in the patterns to cool down any heating that comes from the chip. You know, we mentioned earlier about the satellites. In traffic control, if you look at the data, there's a lot of recurring patterns that was noticed by students researching in the Florida University, and they proposed to their Department of Transportation that there's ways to better control the flow of traffic down in Florida, and maybe streamline that. And in trading, in stock trading, you can see a lot of fractal patterns. I wouldn't say it's called insider trading, but it's like sort of. Yeah, and oh yeah, Vincent van Gogh. Yeah, if you zoom in closer to his paintings, you can sort of see the details of the small details changing with his color choices.
Does anybody know the name of that painting?
Sorry.
Easy peasy. Screen.
You'd be surprised.
This is the future of fractals. We're going to be talking about the future of fractals, where we use them, and how they can be used. So this right here is was a model that was actually made by fractals. So if you zoom into all these little textures throughout the mountain, you'll see multiple fractals were used to make it look the way it is. And as we move on, advance further with our technological advances, we get better texture and better texture using more and more fractals for designing things like this mountain right here. And for cell phones too, as we move on in the future, we started with antennas like this, as Monty and Christopher said. And as we move on to the future, we build fractals based, we make antennas now with fractals like this. And as we move forward, we get better at designing the fractals for the chips right here. So our phones can intake more data and dish out more data to satellites, so we get more faster processing and everything like that. And also for cells, they noticed that there's a pattern in cells that that healthy cells had a certain pattern, and non-healthy cancer cells had this pattern. These are blood vessels, and they had the same fractal pattern in the blood vessels, and this is a healthy one, this is an unhealthy one. And basically, as we move on to the future, they're thinking fractals can be used to help describe certain illnesses based off of the formation of their blood vessels. And that's all we have.
Thank you, everybody. Sorry for going a little bit over time, but thank you for listening.